All right, so we worked on solving when the equation had a radical in it. Today we're going to work on when it has exponents that are fractions in it. Okay? So kind of step by step through here. So you see the example up there. It's not actually a radical this time. It's got the 4/3 for the exponent. So you will blank the rational exponent. I can't talk today. Blank the rational exponent expression. What do I want to do with it? Remember the word I used on Friday? Starts with an I. Isolates. Some of you didn't like my word. You wanted to use like get it by itself or whatever. Yeah, so isolate the rational exponent expression. So the part that has the fractional exponent, and get that part by itself. Okay? Raise each side of the equation to the blank of the exponent. What would cancel a 4/3? Say it again. 3/4. If I have a 4/3 and then a 3/4, they'd be one top and bottom. You can cancel them out, right? So what's that called when you take the fraction and flip it over? Reciprocal. Okay, so you raise each side of the equation to the reciprocal of the exponent. If the denominator of the new fraction is even, this is one of those things in math that it's just like one of those weird rules that you just have to remember. Okay? If the denominator of the new fraction is even, the right side of your equation will be plus minus. So stop and think for a minute. If the denominator is even, that's the root number. So if you take the square root of something, your answer is plus minus. So same goes for a 4th root, 6th root, whatever. Those answers are plus minus. And then make sure you check each answer to make sure it works. All right, so here we go. Number 1, we want to solve. Can I distribute the 4 into the parentheses? You cannot. Stop and think for a minute. This has an exponent on it, which is what makes it that you can't. The other way to think about this, don't write this down. This is actually the cubed root of x minus 3 squared. That's what that's actually saying. Would you even dream of distributing into that? No. You'd be like, it's under a radical. I can't do anything. So that's what this is actually saying. So I cannot distribute into that. All right, but to get rid of it, I can divide by 4. Solve x minus 3 to the 2/3. 64 divided by 4 is what? 16? Thank you. All right, so I have the part that I need to get rid of the exponent. I have it by itself. So then I will raise both sides to the reciprocal. The reciprocal of 2/3 is 3/2. And if I do it to one side, I'm going to have to do it to the other side. And again, to make sure you understand why we do this, we talked a lot before about how fractions, like how they work. 2's on top and bottom. I have 3's. They're going to cancel each other out, right? So the exponent's really just 1, which is like nothing. So I have x minus 3. And then what is 16 to the 3/2? Yes, it is. Okay. When we get to this point, you can go ahead and type that in your calculator. But Carrie's right the way she said that. She said the square root of 16 to the 3rd. Or you could think of it the other way. What's the square root of 16? It's 4. And what's 4 cubed? 64. So again, you can type this in your calculator, 16 to the 3/2 power. You can type it in. But the way I always do them, because I like to do things in my head, that bottom number is a 2. That means the square root. The square root of 16 is 4, and 4 to the 3rd is 64. So that way, and I can do those in my head that way. Now, remember that funky rule we just talked about? That's even. So if that is even, the answer I get from this is plus minus. If this was odd, then I don't care. I don't have to worry about it. But if that is even, this answer is plus minus. That doesn't necessarily mean your final answer, I just stick a plus minus on it. The answer from that is plus minus. Now I will get x by itself. right? So I have to add the 3 over here. So 3 plus or minus 64. Hopefully it looks familiar when I used to write it that way. What's 3 plus 64? 67. And 3 minus 64. There you go. So if you're like, did I do that right? And you're not quite sure, then just go back to the original problem and plug it in. So take a minute, go ahead and try that. Grab your calculators. So again, we go back to the original. So I would do 4 parenthesis 67 minus 3, close parenthesis, raise that to the 2/3, and then see if it equals 64. It does. You can go back in, change the 67 to a negative 61, and it also equals 64. Okay. The most common mistake students make, they'll remember this. We'll do a lot today. You'll like get that stuck in your head. You'll remember the even part, but then they get down to the bottom and they're like, yep, 64. They add that, like 67 is plus or minus 67. They stick it on the end. That's not where it goes. Okay. It goes to whatever that answer was. Right. When you saw it was even, that answer, plus minus on that, and then solve from there. All right. Number 2. So this time I don't have like a whole parenthesis that I have to worry about. So I need to get what by itself? The x or the 5x? The x. What's the exponent on the 5? That's a 1. I don't want that one. So do I move the 5 or the 12 first? The 12. So 5x to the 1/4. Add the 12. Gives me 30. And again, that's another mistake people make, that I don't want just the 5x to by itself. I got to get rid of that 5. So divide by 5. So x to the 1/4 equals 6. How do I get rid of the 1/4? What is the reciprocal? 4 over 1. So again, you can kind of look through here and see 1's cancel, 4's cancel, so that's just an x. And what is 6 to the 4th? And 90 what? 96? And then x is by itself. Do I need a plus minus on that? Why not? This is odd. That's odd, so there's no plus minus. How are we feeling so far? Okay. So why don't you guys go ahead and try number 3 on your own. All right, so what number did you get rid of first? The 4. Good. So the 3 is still there. So we have to add 4. It's going to give you 81. Divide by 3. You cannot distribute into that. So x plus 5 to the 3/5. 81 divided by 3. Good. Then we raise this to the reciprocal, which is 5/3. Right. That allows these to cancel. And I have just x plus 5. That's going to be 243. Thank you. Plus minus? No, because that's odd. Good. Subtract the 5. So we get x equals 238. Anybody else panic when they got a number that big? No? Good. Good. You can plug it back in. Yeah, go back to the beginning, type it all in, see if it works. Yeah, especially with these guys, like there's no reason to miss these because you can check them. The only way you should possibly maybe miss something is if you forget that plus minus and you forget an answer. All right, so number 4. You have 2 options here. That's what I would do. Okay, we can rewrite this so that it has a fraction for an exponent, and then I can get rid of both parts at the same time, right? Just by doing the reciprocal. Or you could go ahead and isolate this. You could raise both to the 3rd power to get rid of this. Then you'd have to do the 5th root to get rid of that. So you could, but I think the easiest way is to switch this to x plus 2 to the 5/3. Because now I can get rid of the cubed root and the fifth power all in one step. And you guys know I am a lazy mathematician. So I'm going to try to get rid of as much in as few steps as possible. All right, so we go ahead and flip that, remembering that roots grow underground. Do I get rid of the 2 or the 7? Good. Get rid of the 7. So 71 minus 7, 64. Do I distribute the 2? No, I can't distribute that. So we divide by 2. Which is going to give us 32. Then what? Reciprocal. So that would be 3/5. Okay, so I can see that 5's cancel, the 3's cancel, so I have just x plus 2. 32 to the 3/5 is 8. And again, because what I'm really doing here is the 5th root of 32, which is 2, and 2 cubed is 8. Plus minus? No. This is odd, so no plus minus. Subtract the 2, so we get x equals 6. And again, if you're not confident in your answer, you can check it. This is not one that it is required, because you just have the 1x, so you're okay. All right, number 5 on your own. All right, thank you. All right, so we need to get rid of the 2 and the 4, and what do I got to do with this? Good, so it'd be x plus 2 to what power? Good, 3/2. Remember, roots grow underground, so. And I'll go ahead and add this at the same time. Add that over, gives me 250. Divide by 2. So x plus 2 to the 3/2 equals 125, which would be 2/3. All right, so those cancel, that cancels. I have just x plus 2. And that is plus minus? What? There's a 2 on there. It's not the bottom. Yeah, we'll always look at the bottom one. All right, so then solve here. So we get x equals 23. All right, questions with the more basic ones. All right, so moving on to some that get a little trickier is looking at some where the answers don't always work. So these are the ones where you're going to have more than one x that we really need to kind of look at and see if they work or not. What? Because sometimes in math you get things that don't work out right. Like if I get a number that I plug underneath the square root and it gives me an imaginary answer, like that causes problems sometimes. Yeah, I know. It's those darn like radicals that give us issues. That's where things sometimes don't work. All right, but what do we call the answers that don't really work? Extraneous. They're called extraneous solutions. I know it's kind of deceiving when you're like, I do everything right, all my steps for solving, I followed every math rule there was, and I get an answer and it doesn't work. But yeah, sometimes that happens. Sometimes. Or sometimes people get answers like, sweet, I got an answer, and they move on. Yeah, you gotta check that. Make sure it really works. All right, so number 1 here. So now this one does not have an x on both sides. Can you tell me right now, just by looking at it, what the problem is, Lou? Okay. What he just said, hold on. He was rewriting this as 2x plus 1 to the 1/2 equals -3. Totally fine. You can switch it. Did we switch them when I first taught you how to do these on Friday? How do you undo a square root? You square it. Which I'm glad that you brought that up, because look at that correlation there. Because what's the reciprocal of 1/2? It's 2/1, or just 2. So when I told you that all you have to do here is square it, that's why. Because it's to the 1/2 and the reciprocal is 2. So that's why that works. Okay. So if I do that, I end up with 2x plus 1 equals, what's -3 squared? +9. Elevia, can you put that away, please? All right, to solve here, then we'll get 2x equals 8 and x equals 4. Right? Now this one does not have an x on both sides. Check it for me. What happens? What do you get? Get a positive 3. I don't get a negative 3. Take a look at the original problem. It has the square root of something equals negative 3. Square roots will never equal negative. So this answer actually doesn't work. There is no solution. If you plug this number in here, 2 times 4 is 8, plus 1 is 9, square root of 9 is 3. So you get 3 equals negative 3. No, it does not. Okay. Now, some of you might be able to just look at that and recognize square root equals negative number. Nope. You wouldn't even have to show me anything. If you see that and recognize it, then I don't have to worry about it. Okay? But we need to make sure we're checking things. But back to the question of why do some answers not work? Well, I can solve this and it looks great, but when you square negative numbers, it made them positive. So then you can go through and solve, but then when you plug things back in, it actually won't check out. Okay, so sometimes that happens with math. All right, number 2. So what do I do? Good, I'll square both sides, right? Raise this to its reciprocal, 2 over 1 or just 2. That way that cancels. I have just x plus 7. X minus 5 squared. What's that mean? Means I have it twice. X minus 5 times x minus 5. Because what does it mean to square something? What's 5 squared? Why is 5 squared 25? Because 5 times 5 is 25. You multiply it by itself. So x minus 5 squared is x minus 5 times x minus 5. So we'll have to distribute this. So we get x squared minus 5x minus 5x plus 25. So x squared minus 10x plus 25. So we just got to remember, when you square a whole quantity like that, write it twice and actually distribute it. How do I solve something like that? Good. Set it equal to 0. So 0 equals x squared. Subtract the x over. Gives me negative 11x. Subtract 7. Positive 18. How does that factor? X and x, what are my signs? Both negative. Good, 9 and 2. So then x equals 9 and 2. So when I go back to the beginning, I need to check this. How do I check when I have 2 answers? Good, I use one and then the other. So I'm going to plug in 9 first. So 9 plus 7 to the 1/2 is what? That's 4. So I get 4 on this side. 9 minus 5 is 4. So did the answer of 9 work? Yeah, I got 4 on both sides, so that one worked. Okay, check the other one. So if I plug in a 2, 2 plus 7 to the 1/2. What's 2 plus 7? Wow, nobody can tell me what 2 plus 7 is? It's 9, thank you. 1/2 means square root, so what's the square root of 9? That's 3. Again, you can type this in your calculator. On this side, 2 minus 5. It's negative 3. That one don't work. That one's extraneous. So guys, honestly, when I'm looking at homework, tests, whatever on these, don't erase it. Just go ahead and put an X through it, cross it out, scribble it out, whatever. That way I at least see that, like, yes, that came through as an answer, but you recognize it didn't work. Okay? So go ahead and just leave it there, just kind of put a cross through it, whatever. So I know that you know it's extraneous. Questions here before moving on? Number 3. What do we got to do first? Subtract the 4? Add the 4? So x plus 6 to the half power. What's x plus 4? Thank you. I was waiting for somebody to tell me 4x. Yeah, if you write 4x, that's multiplying. We just want to add it. So it's x plus 4. Okay, how do I get rid of the 1/2? I square it. Right, that gets those 2's to cancel. So I have x plus 6, x plus 4 squared. X plus 4 times x plus 4. Yay, now I get to multiply these. All right, when I distribute this, I'll end up with x squared. Are you going to yell at me if I skip a step? Plus 8x plus 16? You get 4x plus 4x, which is 8x. All right, so you have to distribute all this. And that's what you get. Set it equal to 0. Good. So x squared. Subtract the x gives me 7x. Subtract the 6 gives me 10. Good. 5 and 2. So x plus 5, x plus 2. So x equals -5 and -2. All right. So checking. Right. Back to the beginning, I'm going to plug in a -5. See if it works. Does -5 work? No? What do you get on this side? Good, because -5 plus 6 is 1. The square root of 1 is 1. 1 minus 4 is -3, not -5. That one didn't work. Does the -2 work? Yeah, that one actually works. Yep, that one works. Again, don't feel like you have to do it in your head. Just type it in, okay? You can type those right in the calculator. All right. It just looks kind of weird, right? Why don't you guys try number 4 on your own? All right, guys. So first thing, isolating your radical. So we subtract the 6. So x minus 6. To get rid of the radical, we have to square both sides. So x equals, distributing all of that out will give you x squared minus 12x plus 36, right? Because you have 2 of those. Let me distribute. Bless you. Set it equal to 0. So subtract the x, gives me -13x. Factoring, that's going to be x minus 9 and x minus 4. So x equals 9 and 4. Then we have to check, right? So if I plug in the 9, right, 9 here, 9 there. So 6 plus, that's going to be 3. 6 plus 3 is 9, so that one worked. And then we plug in the 4. So 6 plus, that's going to be 2. 6 plus 2 equals 4? No. 6 minus 2 is 4, but not plus. So that one is extraneous. Will one of them always be extraneous? Not always. Sometimes they both work. Sometimes neither one of them work. All right. Oh, I got 2 of them. So what's my first step when I normally have something that looks like that? What did I do with it? What do I have to do with the part that had the fractional exponent? I had to get it by itself. Can I get both of them by themselves? Yeah, if I have one on one side, one on the other, they're both by themselves. Now, so I'm going to leave this one sitting here, the 5x plus 7 to the 1/2. When I move that one, what changes? So this minus sign right here is going to turn into a positive. Does this one change? It does not. It'd be no different than you writing minus x to the 1/2 and like moving this over. The only thing that changes when you move is that initial sign in front of it. okay? So when I move this, it still is 2x minus 5. So that didn't change. The sign that changed was that one in front. That minus changed to a positive when I moved it over. So I have to raise them to what power? 2? 2 over 1 or 2? Because when I do that, I can get the 2's to cancel. So I have 5x plus 7. 2's cancel in that one. I have 2x minus 5. Well, how easy did that problem just become? Pretty easy, yeah. So I'll subtract 2x, give me 3x. Subtract the 7, gives me negative 12. So I get x equals negative 4. Where do I put that to check it? I put in for the x and which part of the problem? Like, where do I go? Very beginning. You always go back to the original. Okay, so I'm plugging in negative 4 right there and right there. So again, grab your calculator. And I want to see what happened. You got what? No real answer. All right, what did anybody else get? His calculator says non-real. So if you're typing the whole thing in at once, though, what does your calculator tell you? It said jankies? Cool. You got a Scooby-Doo calculator. You got a decimal? Domain error? Okay. That's what I was expecting to hear. So depending on your calculator, his says non-real, hers said domain error. Does that mean it's not a good answer? Doesn't necessarily mean it's a bad answer. Let's take a look and see what it means. What's 5 times negative 4? Plus 7 is negative 13. The problem is negative 13 and the 1/2 means the square root of negative 13, which is an I. Your calculator can't handle that. But what would this one need to be for this still to work? If this is still the square root of negative 13, the square root of negative 13 minus the square root of negative 13 would still be 0. So 2 times negative 4 is negative 8 minus 5. It's negative 13. So is it a good answer? Yes, it is. Because the square root of negative 13 minus the square root of negative 13 still is 0. So that answer is okay. So when you have your calculator and you type stuff in and it gives you an error, domain, something like that, don't automatically assume it's wrong. Just go back and kind of just see what that number is that's in there before you take it to the exponent to see if it's negative. And if so, try them both and see if it still equals to what you want. Sometimes it will, sometimes it won't. Okay? All right. Let's take a break for a minute. All right, guys, number 6. So it's already isolated, right? They're already on both sides. But what do you notice? They're different fractions. So I need to raise both of them to a number that I can get my denominators to cancel, right? Because I want the fraction to go away. So what would you raise them to? I heard an 8. I heard a 4. It'd be 4. Yeah, common denominator between 2 and 4 is 4. Okay, so I've purposely, every time I've done this, I've kind of crossed the things out, just kind of get that in your head. Because when I go to cross things out here, what happens? I cross out my 2, and this 4 becomes a 2. So I have x minus 1 squared. It's not a fraction, so I'm okay. And then on this side, 4 cancels, and I have just 2x plus 1. Oh. Do we know what to do with that? What's x minus 1 squared? Good, means I have 2 of them. X minus 1, x minus 1. Yes. So we'll go through it step by step, though, for you. So we get x squared minus x plus 1. Okay, so x minus 1 squared means I have 2 of them, so we distribute. I'll clean up this a little bit. So I get x squared minus 2x plus 1. And then how do I solve this? Good. Equal it to 0. So I'll subtract 2x over, and I get negative 4x. Subtract the 1. I cancel. And everybody panics and doesn't know how to factor it, right? I don't want to add 4x. Thank you. They got your x. You got a GCF in there. So that's x minus 4. So what does x equal? 0 and 4. If you have an x squared, we need to make sure we're setting equal to 0 and we factor it. Oh, okay. Now I got to check this. But I have to check it in the original. And I threw the problem. There we go. All right, so I have to check up here. So let's check the 0 first and see what happens. So 0 minus 1 is negative 1, and the square root of negative 1 is, if you type it in your calculator, you get an error. Because this is the square root of negative 1. That's what that becomes, which is I. That's I. Do I get the same thing over here? 2 times 0 is 0. 0 plus 1 is, and what's the fourth root of 1? Is 1. So does 0 work? No. All right, so that didn't work. Let's check the other one. So I have 4. So 4 minus 1 to the 1/2 power is, what's 4 minus 1? 3. To the half power is the square root of 3. The other side, 2 times 4 is 8, plus 1 is 9. So this one is the fourth root of 9. Are those the same? Type them in your calculator. Is the decimal the same? Mm-hmm. Yeah. These two things are equal. So 4 is a good answer. Again, looking at it like that, you might not recognize the square root of 3 is the same as the fourth root of 9. You may not recognize that, but they are the same. Questions? I know that can get confusing. All right, number 7. Savannah? Yes. So I need to isolate, so this one's got to go over there. So 11x plus 45 to the 1/4 equals, does the sign inside the parenthesis change? No. So equals x plus 5 to the 1/2. So just that minus is what changed when I moved it over there. Savannah? Yes. Yep. So I will raise them both to the 4th power. You want the biggest one, because that way you don't have any fractions left over. So like if one of them was a 1/3 and one of them was a 1/6, I'd raise them both to the 6. Yeah, because you want to be able to get rid of both of them. So here this one's going to cancel, and I have just 11x plus 45. What happens on that one? Yeah, that 2 is going to cancel, and the 4 is going to become a 2. So that one's x plus 5 squared. All right, squared means I have 2 of them. So we'll have to distribute. So we get x squared becomes plus 10x plus 25 when I distribute all of that. So you're starting to recognize that pattern of when you're squaring something, how those work. How do I solve? Good. Set them equal to 0. So move that over. We get x squared minus 11x minus x minus 45 minus 20. So you said 4 and 5, which I agree. Which one's negative? So x equals negative 4 and 5. What do I have to do? Got to check this. So if I plug in a negative 4, if I type it straight in my calculator, does it work or do I get any error messages? You got 1? It equaled 1, not 0? Did you go back to the beginning? So it equaled... Oh, you just plugged it in the first one. Yeah, I was asking if you plug the whole thing in, the whole thing, do you get equal 0? Or did it give you an error? I was just asking. I mean, personally, guys, I would start with just plug it into the original all the way across, see if it equals 0. And if you get like that non-real domain error or something, then I'd go back and be like, all right, there must be a negative under a radical somewhere. Then I'd go back and try to fix it. Does it work? Does negative 4 work? It does. Like you said, this one gave you 1. Negative 4 plus 5 is 1. To the square root of 1 is 1. 1 minus 1 is going to be 0. So that one worked. What about 5? You're going to say no. How about we actually do the math and see? You plugged it in, it worked? Everybody else confirm? Okay, good. Again, if you kind of look through this, this one would give you, that's 55 plus 45, so I get the 4th root of 100. This one becomes the square root of 10. Those are actually the same thing. Yeah, and that's totally fine. Go by decimals, type it in, see if it works, and it does. So both answers are okay. Had to be the same. Yep. All right, number 8. What do I do with that? Yeah, it's like what we did on Friday. So I can square both sides, or I could change this one to 2x plus 28 to the 1/2, like what we were doing today, and I can do it the same way. Either way, you end up squaring both sides. X plus 2 squared means I have 2 of them. And then that will just cancel my radical. X plus 2 times x plus 2. Good. All right. And then I have an x squared, so I've got to set it equal to 0. I will subtract the 2x, gives me 2x. Subtract 28, gives me negative 24. And then we have to factor. Good. X plus 6 and x minus 4. So x equals negative 6 and 4. Good, moving on, 1 to go. Oh, I should check it first. Again, checking all the way back to the original problem. Go ahead and check them for me. Let me know. Do they work or do they not? Okay, she said negative 6 doesn't work. Anybody confirm? Do you agree with her? Yeah. Because if you plug a negative 6 in, negative 6 plus 2 is negative 4. A square root is not going to equal a negative number. So I know that doesn't work. Does 4 work? Yes. So just 4 is my answer. All right, 1 to go. Number 9. What? Yes, you would add the x. Because I need to get this radical by itself, so we need to move the x over here. So positive x plus 4 equals a square root of negative 2x. And then would I do what? Yeah, you would square it then. Because if I square it, it gets that radical to go away. So x plus 4 squared means I have 2 of them. That squaring will just cancel out my radical. All right, x plus 4 times x plus 4 will be x squared plus 8x plus 16. Setting it equal to 0, x squared, add the 2x, gives me 10x. How does that factor? Good. X plus 8, x plus 2. So then x equals -8 and -2. Now, when we check this one, be careful. There is an extra minus sign in front of that x. Right? So when I plug -8 in here, you're going to have minus -8. Okay? Don't miss those double signs in there. So let's go ahead and plug in a -8 first and see what you get. Oh, I hear a lot of things. I heard it worked, and I heard, yeah, because -8 here, -2 times -8 is 16. Square root of 16 is 4, and this becomes a plus, right? So 4 plus 8 is 12, not 4. That one won't work. What about -2? Because this is going to give me 4. Square root of 4 is 2. 2 plus 2 is 4. That one works. So how important is it to check your answers? Very. Also, if you give me an answer and it clearly doesn't work, I'm like, what the heck, dude? Just check your answers. You'd have seen that didn't work. Okay? Let's make sure you plug them in.